Hello Year 11 Mathematics Extension 1 students. Today we're continuing on with the topic of polynomials and we're learning about the remainder and factor theorem. So the remainder theorem is what we're going to start off with today. So the remainder theorem is if a polynomial px is divided by x minus k, then the remainder is pk. So let's have a look at this. So px equals ax qx plus rx, where our ax is what we're dividing by, which equals x minus k. So if we substitute this in, we'll have px equals x minus k times qx plus rx. So the degree of ax is 1, so the degree of rx must be 0, because for our remainder, our degree of our remainder must always be less than the degree of our divisor. So our rx equals c, where c is a constant. So therefore our px equals x minus k times qx plus our c. If we substitute where we have x for k, we'll have pk equals k minus k times qx plus c, where k minus k is 0 times qx plus c, so that means pk equals c. So that means that pk must equal the remainder. Let's have a look at some examples. So we want to find the remainder when 3x to the power of 4 minus 2x squared plus 5x plus 1 is divided by x minus 2. So we're going to say for this x minus 2, this is our x minus k. So therefore our k equals 2. So we're going to substitute 2 into our polynomial to find our remainder. So 3 times 2 to the power of 4 minus 2 to the power times 2 to the power of 2 plus 5 times 2 plus 1. So this equals, when we put this into our calculator, it equals 51. So therefore, the remainder of px is 51. Moving on, we want to evaluate m if the remainder is 4 when 2x to the power of 4 plus mx plus 5 is divided by x plus 3. So we have our x plus 3 here, so that means we'll have x minus k. So therefore our k is going to equal negative 3. So let's substitute that into our equation. And we know that this equals 4. So we have that p of minus 3 equals 4, because it says evaluate m if the remainder is 4. So we know that. So let's substitute minus 3 in. So we have p of negative 3 equals 2 times negative 3 to the power of 4 plus m times negative 3 plus 5 equals 4. So then 2 bracket negative 3 to the power of 4 equals 162 minus 3m plus 5 equals 4. So then 162 plus 5 is 167. So we have 167 minus 3m equals 4. We're going to plus our 3m to both sides to make this positive. So we'll have 167 equals 4 plus 3m minus 4 from both sides. So we have 3m equals 163. We then want to divide both sides by 3. So m equals, as a fraction, 54 1/3 is what our m equals. moving on now to our factor theorem that states where the factor theorem is a direct result of the remainder theorem. Our factor theorem is for a polynomial px, if pk equals 0, then x minus k is the factor of the polynomial. So let's prove this. So we have px equals x minus k qx plus rx. All we've done there is substituted our ax out for our x minus k. So the remainder theorem states that when px is divided by x minus k, the remainder is pk. So we're going to change out our rx for our px. So we have px equals x minus k qx plus pk. But if pk equals 0, we substitute our pk out for 0. So we have px equals x minus k times qx plus 0. So px just equals x minus k times qx. So that means that x minus k is a factor of px because there is no remainder. The converse of the factor theorem is also true, where for a polynomial px, if x minus k is a factor of the polynomial, then pk equals 0. So the opposite, if you're given a different piece of information first. So for example 3, we want to show that x minus 1 is a factor of px equals x cubed minus 7x squared plus 8x minus 2. So what we're going to do is we have our k equals to 1. So we're going to substitute in we're going to substitute 1 into our polynomial. So we're going to find p1. So 1 cubed minus 7 times 1 squared plus 8 times 1 minus 2 equals 1 minus 7 plus 8 minus 2. So 1 minus 7 plus 8 minus 2 equals 0. So once we get 0, therefore our x minus 1 is a factor of px, and so we've solved that. So then part 4, or example 4, we want to divide px by x minus 1 and write px in the form of px equals x minus 1 qx. So we want to divide, so we need to write x minus 1 here. Our division, make sure you leave a little bit of room to write the answer on the top. I'll write your qx. Write our polynomial underneath. Okay, and now let's divide. So we go x divided by x cubed is x squared. Then x squared times x is x cubed. And x squared times minus 1 is minus x squared. And then we subtract these. So x cubed minus x cubed is 0. Negative 7 minus negative 1x squared is negative 6x squared. We then bring our plus 8x down. So then we go negative x squared divided by x. So that's negative 6x there. So we have negative 6x squared, and then negative 6x times negative 1 is plus 6x. We subtract those. So negative 6 subtracted by negative 6 is 0, and then 8 subtracted by 6 is plus 2x. So then 2x divided by x is plus 2. We bring our minus 2 down. And so then we have 2 times x is 2x. And 2 times negative 1 is negative 2. Subtract 2x minus 2x is 0. Negative 2 subtracted by negative 2 is also 0. So therefore we want to write it as p x equals x minus 1 qx. So we have x cubed minus 7x squared plus 8x minus 2 equals x minus 1 in one bracket and x squared minus 6x plus 2 in the other bracket. Moving on. So some properties of polynomials come from the remainder and the factor theorems. The zeros of the polynomial are those values for which px equals 0. So you have some properties of polynomials here. So if a polynomial px has n distinct zeros, k1, k2, k3, all the way to kn, then x minus k1 times x minus k2 times x minus k3, all the way to kx minus k to kn is a factor of px. If a polynomial px has degree n and n distinct zeros, k1, k2, k3, all the way to kn, then the polynomial px equals an times x minus k1, x minus k2, x minus k3, all the way to x minus kn. A polynomial of degree n cannot have more than n distinct real zeros. A polynomial of degree n with more than n distinct real zeros is the zero polynomial. So that's where the coefficient of each of our pronumerals or our x's is 0. If two polynomials of degree n are equal for more than n distinct values of x, then the coefficients of like powers of x are equal. So if an xn plus all the way to a2x squared plus a1x plus a10 is congruent to bn xn plus all the way down to b2x squared plus b1x plus b0, then our an equals our bn, our a2 equals our b2, our a1 equals our b1, and our a0 equals our b0. Let's have a look at some examples. So what we have here is we want to write x cubed minus 2x squared plus 5x in the form of ax cubed plus b times x plus 3 all squared plus c x plus 3 plus d. So what we need to do here is we need to first look at our form and we need to expand that. So we have ax cubed plus b times x plus 3 plus 3 all squared plus c bracket x plus 3 plus d. So we're going to expand that out. So we have ax cubed plus b times x plus 3 times x plus 3 plus c times x plus 3 plus d. So we have ax cubed plus b times x squared plus 6x plus 9 plus c bracket x plus 3 plus d. So now we're going to times our coefficients in. So we have ax cubed plus bx squared plus 6bx plus 9b plus cx plus 3c plus d. And then we're going to collect like x's, so like terms. So we have ax cubed plus bx squared, and then we're going to collect our x's. So we have our 6b plus our cx, and then we're going to collect our coefficients. So 9b plus 3c plus d. So then for our equation x cubed minus 2x squared plus 5, this is equal to ax cubed plus bx squared plus 6b plus cx plus our 9b plus 3c plus d. So what we want to do is we want to find our equating coefficients. And so we say that they're congruent to each other. So 3 horizontal lines going down. So we can say that for our value of a, it is our coefficient of this x cubed. So therefore, our a equals 1. For our b, it is the coefficient of our negative 2x squared, because that's where our x squared is. So we'll then therefore say that b is equal to negative 2. For our next values, for our x, we do not have equal to anything on this side. So that means that our 6b plus c is just going to equal 0. And so we want to find out what c is here. So we're going to sub in b, so it will be 6 times our minus 2 plus c equals 0. So we have minus 12 plus c equals 0. So then we plus the 12 to both sides. So therefore we have our c equals 12. And then we need to find out what d is. So for our constants, we have 5 equals to 9b plus 3c plus d. So we go 9b plus 3c plus d equals 5. We subs in our b and our c because we already know them. So 9 times minus 2 plus 3 times 12 plus d. And now we're trying to solve for d. So we have minus 18 plus 36 plus d equals 5. So negative 18 plus 36 is just 18. So 18 plus d equals 5. I'm just going to come up here. We want to, however, subtract 18 from both sides. So therefore our d equals 5 minus 18, which is negative 13. So therefore we have that our x cubed minus 2x squared plus 5 is somewhat equal to x cubed minus 2 bracket x plus 3. Actually, I'm going to write it down here. Is congruent to our a, x cubed, which ax cubed is, a is just 1, so it will be x cubed, plus our b bracket x plus 3 all squared. So where our b is minus 2, so minus 2 bracket x plus 3 all squared, plus c, so our c is 12, so plus 12 bracket x plus 3, and then plus our d on, which is negative 13. And that's how we answer that question. Now we're going to talk about factorizing polynomials. So if x minus k is a factor of px, then k is a factor of the constant term of the polynomial. So for example 6, we want to factorize each polynomial. So what we're going to do here is we can try out factors and then we're going to divide. So we're going to try factors of 12, so of our constant, whatever your constant is, you want to try factors of that. So our factors of 12 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So we're going to have a little bit of a play around. So we're going to sub in p of 1 and see if that works. So when we sub that in, so we'll have 1 cubed plus 3 times 1 squared minus 4 times 1 minus 12 equals, so 1 cubed plus 3 times 1 squared minus 4 times 1 minus 12. Now that equals negative 12, so that can't equal 0. So therefore, this is the same as x minus 1 is not a factor. So then we try something else. So let's try 2 by subbing in 2 into our equation. So polynomial of 2. So 2 cubed plus 3 times 2 squared minus 4 times 2 minus 12. So 2 cubed plus 3 times 2 squared minus 4 times 2 minus 12. That does equal 0. Oops. So therefore x minus 2 is a factor. So then we're going to divide our polynomial by x minus 2. So we have, we'll go back to black, x minus 2 divided by, we're dividing x minus 2 by x cubed plus 3x squared minus 4x minus 12. So x cubed divided by x is x squared times x is x cubed, x squared times minus 2 is negative 2x squared. Subtract x cubed minus x cubed is 0. 3 minus negative 2 is plus 5x squared. Bring our minus 4 down. So there we get 5x squared divided by x is plus 5x. So 5x times 5x times x is 5x squared. 5 times minus 2 is negative 10x. Subtract. So 5x squared minus 5x squared is 0. And then we have minus 4 subtracted by negative 10 is 6x. Bring down the minus 12. I'm running out of room. Bring down the minus 12. So then we have 6x divided by 6 is plus 6. And then this is 6x minus 12. And so 6x is 0. Minus 12 minus negative 12 is also 0. So therefore, our polynomial equals our x minus 2 times x squared plus 5x plus 6. So we can then factorize our quadratic. So we have our x minus 2, and then our x squared plus 5x plus 6 will be the same as x plus 2, x plus 3. So we have therefore factored our factorized our polynomial. So then looking at b, we want to factorize this. So we have px equals x cubed plus 3x squared plus 5x plus 15. So we're going to try factors of 15. So that's plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. So let's sub in p of 1. That's the first one that we always sub in. I like to just sub it in into my calculator. So 1 cubed plus 3 times 1 squared plus 5 times 1 plus 15. That doesn't equal 0. Okay, so that's not going to be what I sub in. What about p of 3? So 3 cubed plus 3 times 3 squared plus 5 times 3 plus 15. That doesn't work. Okay, let's try the negatives of that. Let's try negative 1. So we sub in negative 1. So negative 1 cubed plus 3 times negative 1 squared plus 5 times negative 1 plus 15. That equals 12. That doesn't work. Let's try negative 3. So we have negative 3 cubed plus 3 times negative 3 squared plus 5 times negative 3 plus 15. Yes, that equals 0. So then I write it out just to save paper, but I have tried other ways. So negative 3 cubed plus 3 times negative 3 squared plus 5 times negative 3 plus 15 equals 0. So therefore x plus 3 is a factor. So now we can divide x plus 3. So we have our x cubed plus 3x squared plus 5x plus 15. So x cubed divided by x is x squared. X squared times x is x cubed. X squared times 3 is plus 3x squared. X cubed minus x cubed is 0. 3x squared divided by 3x squared is 0. So then, because that equals 0, we bring down our plus 5x and we bring down our plus 15. So then we have 5x divided by x is just plus 5. So we're going to put that there. And then we'll have 5 times x is 5x, and 5 times 3 is 15. 5x minus 5x is 0. 15 minus 15 is also 0. So therefore, our px equals our x plus 3 times our x squared plus 5. And we can't simplify that in any